Question number 2 of the assignment. Yes, assignment. I think Fahad also asked me last 3-4 questions. Which assignment you are talking about, Abia? I remember Fahad's questions. Fahad, I'll send you by tonight. All right, Fahad.
Okay, ma'am. No issue.
Okay. Abia, I'll explain. This is from the recent assignment. Resistance between the two ends of the legs. Yes, I think this is from the resistivity and resistance assignment. No? Let's complete off the chapter today. Then doubts I'll discuss. Kirchhoff's law we had started. The revision can only be done with the help of questions only. So see, question 2. Darshan, were you there in the last class? Were you coming from the last 2 classes? No, you weren't there. All right. So it will be difficult for you to understand Kirchhoff's law if you don't have any idea. Though just to understand, wait for a few minutes. We'll be over with Kirchhoff's law and then the next topic you'll be able to do. Let's take a circuit. So the revision of this will only be done with the help of circuits. Let's name these points P, Q, R, S. So we have named these points. So how many loops can you see? Yes, how many loops are possible? 2. Yes, 2 loops are possible. One is this, other one is this. Let's go in any direction where we want. Okay, before that, let's choose the current. So let's say I1 current has started from here. All right, I1 has started from here. Yes, that's 2 loops are there. So I1 current randomly I have taken that I1 current has started from here. So I2 current will go in this loop, and in this I1 was coming, I2 has gone. So I1 minus I2 will go in this branch. See, this is a single wire, so in this wire or branch also it will be I1 minus I2. This is a single branch, this will be I2, and this branch is having which current? I1 current is flowing. So I1 minus I2, yes, correct. All the corrects have been distributed. See, randomly I've done it in front of you people. I didn't decide, or this wasn't written in the solution anywhere or something that was written, or this was pre-decided that only this has to be chosen as 1 ampere. All right, I1. So anything you can choose, you just have to set in and check in where if all the currents are matching or not. Now let's go in any direction. Let's go clockwise. Clockwise, I hope you know, clockwise will be from P, Q, R, then R to P back. P to Q to R to P back. That becomes, so in this loop, P, Q, R, P in this loop. Now let's start from P to Q. From the positive terminal, we are moving on to the negative terminal. Keep on answering, all of you. If possible, you can write it in the chat box also. Just but keep on answering. Otherwise, this will become very difficult for us to understand. So from positive to negative, minus or plus? Past class. Look into the notes if you're not able to recall it.
Minus 5I1.
Minus, not I1, Fahad, that's the voltage given to you. So voltage is already there. So only minus 5. We write the voltage's value, and if we move from the positive to negative, that becomes what? It basically becomes negative. Now let's move here. So are we moving along the current or opposite to the current? From Q to R, are we moving along the direction of current or opposite to the direction of current? Opposite to the direction of current. And if we move opposite, we write the value of voltage as positive. So this will be plus, and current is I1, resistance is 200, so this becomes 200 I1. Now, last branch is left. Are we moving towards current or opposite? Similar, in this branch also we are moving opposite. So this will be plus, and current is I2, resistance is 20, so this becomes 20 I2 is equal to 0. This is your first equation. Now let's see this loop. Let's move in any direction that we want to. Let's move here also clockwise. So in loop, which loop is this? P, R, S, P in this loop. Now starting from P to R, are we moving along the direction of current or opposite to the direction of current? Along the direction of current. So we'll write a negative sign. Yes. So negative sign, and value of voltage will be 20 multiplied by I2. PQ we have done. Now R to S. R to S, we are moving opposite to the direction of current. So if we are moving opposite to the direction of current, what should be the value of voltage?
Positive.
No, that is positive. A value of voltage. How will you write it? 60 I1 minus 60 into I1 minus I2. Good for. So it will be positive 60 into I1 minus I2. This branch is done. Now current is flowing like this. So we are again moving opposite, and the current in this branch is same, I1 minus I2. So this becomes what? Minus 2 into I1 minus I2. And the last one, from negative to positive we are going. So this will be plus 4 is equal to 0. Two equations are there, two variables are there. Note down this. In one last case, how to prove the balancing condition of Wheatstone bridge, we'll do that. First, note down this. In the PRSP loop, okay, this loop from S to P, yes, we are going in opposite direction. So, okay, I've written negative. Oh, yes. We are going in opposite direction, so this will be plus. Thanks, Fahad. Done. Rufia, are you able to relate with this? Because I think you were also absent in the last class. I think you will be facing difficulties. Don't worry about that. I'll give you the video lecture. We have the recorded lecture for the last class. So if you're able to recall, then it's very good. If you're not, then okay, it's okay, because just by looking at the question, it will be difficult for you. So just wait for this last Wheatstone bridge case, then we'll move on to the next topic, basically the last topic. Yes, Fahad, you have to solve it. Of course, you have to solve it. You have to find out the values of current. I'm not solving because it will take time and it will waste our time. It will just waste our time. Just a second. All right, Fahad. So you have to solve all the equations, I1, I2, what all values of currents that you get, you have to find out. Fine. So don't leave it at this step. This is I am doing because we don't have so much time to get the equations, because Kirchhoff's method is definitely lengthy. You should avoid it when you are able to find out series and parallel combination. When you're able to find out series parallel combination. If somehow you're not able to identify series or parallel combination, then Kirchhoff's law or this method rules. This is a full proof method. By that, you'll be able to get the values of current. Now, Wheatstone bridge we have discussed when we were discussing capacity. Did we discuss? No, I don't think we didn't. We did discuss it. Let me know, students who were there in the last lessons. Fahad, Reem, Rifat. Did we discuss Wheatstone bridge?
No, ma'am.
Okay, we didn't discuss it. Fine, let's discuss it now. Basically, Wheatstone bridge is just an arrangement of the resistors or even the capacitors. That arrangement is known as resistors. So we didn't discuss there, so let's discuss it now. Both the concept will be remaining the same for the resistors as well as the capacitors. So let's do it for the resistors. You can relate it with the capacitors. That will remain the same. So let's take, there are 4 resistors connected. So let's name it randomly. This is R1, this is R2, this one is R3, and this one is R4. So a galvanometer has been connected in between these, and the other two opposite ends, they have been connected to a cell. This is connected to the positive terminal of the battery, and this side is connected to the negative terminal of the battery. Basically, this arrangement is known as Wheatstone bridge. So I think we didn't discuss in case of capacitors, but even if you replace the resistors with the capacitors, the concept will remain the same. You just have to identify the balancing condition. Now, what's the balancing condition in case of a Wheatstone bridge? Balancing condition is if I take the ratios of these two resistors, that is R1 divided by R2, or if we were talking in terms of capacitors, C1 by C2, the capacitance's value. This ratio should be equal to the other two ratio, that is R3 divided by R4. This is the condition of a balanced Wheatstone bridge. So with the help of Kirchhoff's law, we are going to prove this. That this question can come in your board examination. This question is not important from your entrance point of view, but in your board examination, to prove the balancing condition of Wheatstone bridge using Kirchhoff's law, this is a standard question that can come in your 12th board examinations. Now, this is the condition. One thing, potential we all have discussed. For all those people who are not familiar with potential, potential is basically scalar form of the electric field. Electric field, we use it in terms of the vector form, the space around the charge in which the charge is confined and electrical properties can be experienced. That is known as electric field. That is a vector quantity. We use all the superposition principle, the parallelogram law, your triangle law, your polygon law for calculation of electric field, net electric field, basically superposition principle that we call. Similar thing that in terms of potential, we call it in terms of scalar quantity. So when the Wheatstone bridge is balanced at these 2 points, let me name these points. This is A point, this is B point, this is C point, this is D point. So across BD, across these two ends, the potential difference is basically 0. All right, that we'll keep on discussing, but let us first use the Kirchhoff's law to prove it. So Kirchhoff's law, the way we have been using, let's say some I current has been coming out of this battery. That's how we choose. We choose a battery, we take out some current from that battery and distribute it. At A point, are we able to see the branching? Yes or no?
Yes.
Right. So we are able to see the branching. As branching comes, it means current will definitely get divided. Current divides on branching, and voltage divides when you have the breakage like resistors and capacitor. So right now we are not concerned with the potential part. Potential we'll be doing it in the next step. Kirchhoff's first law we use first. First law is what? The current law. So let's distribute the current first. Then we can use the law to find out the value of the potential. So I current is coming. Let's say current gets distributed. First branch, this branch receives current I1. So from I, this branch received I1 current. So how much current will this branch receive now? AD branch. Anyone from the class? I'm saying I current was coming, right? From the battery. Now I1 current has gone to AB. So how much current will be left in this branch? AD. I minus I1. Why it's so difficult? From I1 has gone. So I minus I1 in this branch. Yes or no? I minus I1. Yes, it is I minus I1. Darshan, just wait for 5 more minutes. We'll be just ending this. Was it network issues or did you leave it on purpose by seeing the topics? Darshan. So you just wait for 5 minutes. We'll be starting with the new portion. Okay, Darshan. So we just have to prove the balancing condition. Now, current through this galvanometer is Ig. Supposedly, let's say the current flowing through this galvanometer is Ig. So I1 was coming, Ig has gone. Again, the current left will be I1 minus Ig. I1 was coming, Ig has gone. So I1 minus Ig will be left. Now see, I1 minus Ig is left. In this branch, you have I minus I1. I minus I1 is coming from AD. IG is coming. Total current that this branch will receive will be total I minus I1 plus this IG. Now see, IG gets cancelled, I1 gets cancelled. Only current I flows back. So this shows that all the current division that I have taken in this calculation, all those divisions are correct. It can happen like in one batch I was teaching this topic and by mistake I didn't consider one of the currents. I forgot to add this negative sign. So what happened when I concluded? No, I was able to see that the net current with which I started, that I wasn't getting back. So by that I got to know that there must be some errors that I must have committed while writing it. So I then again checked it. Then I saw that minus I2 or whichever current was there, I didn't write. That's why I wasn't able to get the whole current. So you have to check it also. Like right now, I didn't commit any error. So I was able to get the current I back. Now you just have to apply Kirchhoff's law. Let's say this is clockwise motion. All right. So in loop A, B, D, A, this loop, we are going along the direction of current, that becomes negative minus I1 R1. Then here we are again going along the direction of current. Resistance of galvanometer is capital G. Current flowing is Ig. So this becomes minus Ig into capital G. Lastly, we are going opposite to the direction of current. So this will be positive. So for positive, it will be what? Plus R3I minus I. Now, very important condition that will solve this question very easily. And remember this condition in the exam. By this condition, your whole paper, the whole calculations will become very easy. If the bridge is balanced, what we are trying to prove, what happens, what is the balancing condition? So if it's the balancing condition, then obviously we are considering it balanced. So if your bridge is balanced, then what did I tell? Potential difference will be zero across both the ends, across the galvanometer BD, this end. So what happens? No current flows through the galvanometer. If no current flows through the galvanometer, then the value of this Ig will be simply zero. Always remember. Now your questions become easier. Two loops you can check. Otherwise, three variables were there. I1 was there, I2 was there, I was there, Ig was there. Not I2, I1, Ig, three variables were. If we equate Ig as 0, one of the variables will get reduced. So what will we be left with? This term will become 0. So we'll be left with minus I1 R1. And what else term we'll be left with? Or we can shift this towards the other side. So this becomes R3 into I minus I. First equation. We have the first equation. Now the second loop we have to consider. The second loop is what? BCDB. All right, that is written as BCDB. So let's take clockwise again. Can't take anywhere now. Answer will be the same. So BCDB. In BCDB. Let's start moving. So if we move from B to C, we are moving along the direction of current. I have repeated it so many times. Along is negative, opposite is positive, everything. I hope you people are able to remember it, because Kirchhoff's law is not useful from entrance point of view. But in the examination, if you have to prove a question or if you have to solve using Kirchhoff's law, then obviously you are obliged to use it. So definitely this is lengthy in the sense for the calculation of final answer. These steps are not lengthy. It's just that to get the final equation, no, that can be lengthy, that I understand. Even it takes me also time to solve the equations if there are three equations. So that's okay. But in the exam if it comes. So I hope you are able to remember it. Like from B to C we are moving. Look in the figure, B to C along the direction of current, along is negative. So negative sign will come. Resistance is R2, current is I1 minus Ig. According to Ohm's law, it will be minus R2 I minus Ig. That's the first equation, not the first equation, first portion. Then moving from C to D, we are moving in opposite direction. So that becomes positive. So this will be plus R4, I minus I1 was there and we added Ig plus Ig. This is left. Any other variable is left? I think this much. Oh no, the galvanometer and resistance is left. So if we move from D to D to B back, we are moving opposite to the direction of current. That will be positive. Current is Ig, resistance is capital G. So this becomes plus Ig into G. This much is equal to 0. For balancing condition, Ig will be equal to 0 and you have to put it in the values wherever you see Ig. So this becomes 0, this becomes 0, this whole term becomes 0. See, what are we left with? We are left with minus IR2 from here. Then we are left with what? Plus R4 into I minus I1 equal to 0. So R4 I minus I1 can be written as I into R2. That is the second equation. Write both the equations. Use the two equations. R1 is equal to R3 into I minus I1. Use the second equation divided by I. This will be I1. So I1 minus Ig, you know. This becomes I1 R2 divided by R4 I minus I1. This gets cancelled, this gets cancelled, I1 gets cancelled. Did we prove the condition or not? Hence the balancing condition is proven. R1 by R2 is equal to R3 by R4. That's what I told you in the starting. And this is known as the balancing condition. So with this, we complete with the Kirchhoff's law. We have a very small topic left. We'll do it right now. Why did we divide it? Because there are two equations that you have. Now, how will you do it? If you take them as x and y, so it's better both the equations. Your calculations will be easier. You can subtract. You just have to solve the equations and get the ratio of R1 and R2 to get the balancing equation. So if you divide it, you'll notice that everything gets cancelled, so it becomes easier. If you perform addition or subtraction, it will be very lengthy for you to solve. And we always try to choose the shortest path for the calculations, so as to make our calculations easier. That's why only. Nothing else, nothing special about division. So note down this as well. Yes, Fahad, every time, but just for a balanced wheat stone bridge. If it mentions you that the condition is not balanced, then you cannot take potential at zero. Clear, Fahad? Is your name Fahad or it is Fahad? How do you pronounce it? Anyway, all right, fine. Done or not? So maximum of you have complete. Okay, let's the next topic. It's the last topic, and it's an easy. So this is the last topic, that is combination of identical cells. So how to calculate equivalent EMF and all those things that we have already calculated. Now, if your cells are identical, earlier when we used to do, remember we had the different values E1, E2, and the internal resistance R1, R2. What if all the values of cells are same? So that definitely eases your part. So this is an easy topic. You will be able to do. All of you will be able to do. It's better than Kirchhoff's law. Kirchhoff's law wasn't tough, but in Kirchhoff's law it was lengthy. So equivalent EMF will be what? E plus E plus E. This will, we keep on adding the way we used to add E1 plus E2 plus E3. Now all the values of EMFs are same, so we'll be just writing E. So let's say N is the number of cells that are present. N is the number of cells that are present. So E plus E plus E, and N number of cells are present. Can anyone tell what should be the equivalent EMF for N number of cells? Samya, can you try? E plus E plus E. And if N number of cells are present. Like five cells are present, what will be the value of E? Equivalent EMF. Respond, class. No one is responding. Maximum, what will happen? The answer will be wrong. No, we are discussing only. It's just general discussion. If I give you two cells, each one is having the value of EMF as E. So what will be the equivalent EMF? Samya? 2E, right. So if N number of cells are there, that becomes NE. So it's not difficult. You just have to write it as NE. Similarly, for R equivalent, internal resistance, it will be R plus R plus R up till NR. So what will be the value of equivalent current now? I will be equal to E equivalent divided by R plus small r equivalent. So current becomes what? Current becomes NE divided by NR plus capital R. This is the formula where N is the number of cells present. Now here we see two cases. Both the cases make your calculations easy. If your external resistor that is connected in the circuit is very much greater than your internal resistance, it's like if I'll say a Reem has 1,000 chocolates with her. Reem gives a single chocolate, or let's say Abia gives one more chocolate to Reem. If Reem had 1,000 chocolates and Abia giving that one more chocolate to Reem, will that actually affect Reem's collection of chocolates? No, obviously, amount of chocolates are already huge with Reem. So even if you add one more chocolate, if you give her one more thing, that would affect her collection. She was already rich with chocolates. So just relate it in terms of resistors. If your external resistor is so huge, what was the denominator? Denominator was NR plus capital R. If your capital R is so huge, will this addition of NR differ this value? No. What It's like capital R is acting as those 1,000 chocolates and this NR is acting 1. If you add 1,000 plus 1, you'll get 1,001. That will almost be equal to 1,000. So this can almost be written equal to external resistor. Now see, current's value, equivalent EMF was what? NE. This was the denominator. So instead of this denominator, you have to write capital R only. This is which case if your external resistor is greater than internal resistance. Now, if you see external resistor is greater than internal resistance, try to prefer the series combination. If you get that, we'll see in the question. I'll give you a question, then this portion will clear. Now, vice versa. If your internal resistance is very much high, now let's reverse. Let's say now Abia has 1,000 chocolates and Reem is giving her that one chocolate. Reem is reverting back the chocolate that Abia gave. So Reem is giving her that single chocolate. So what will happen? Reem's collection will now not get affected. Abia's collection will now not get affected. Abia is now Abia is rich with chocolates. She does not require that one chocolate. So even if Reem gives her that one, her collection won't get affected. So just relate again. It's NR plus capital R. This time capital R is huge. So NR becomes greater. NR dominates, and this NR. In this NR, you're adding just capital R, and capital R is so small right now. So it's insignificant. You can write it as NR simply. So what was the value of current? N capital E. This was the denominator. Now we'll write the denominator as NR. N gets cancelled. Value of current is E by R. Now see what I was telling you. I was saying that you have to prefer series combination if external resistor is greater. Reason, okay, let's do it later on. Let's first do parallel combination, then you will be able to understand why did we do. Now, just in order to differentiate, n number of identical cells were considered in series. Let's take a different variable m as the identical cells connected in parallel. Now we are talking about the parallel combination. An open question for the whole class. Let's see who can answer this question, because I have asked this question in many batches and maximum students have answered this incorrectly. Can anyone tell me, or everyone write me in the chat box, what according to you should be the E equivalent right now? Everything is written in front of you. Everything I have written before the class. Everyone write me in the chat box, according to you, what should be the value of E equivalent? Okay, Samia has answered. Others? Others also respond. Whatever you think, whatever. I just want to know what the class feels. I'll tell you the correct answer. And I hope Darshan and Rufia, it's getting better from this portion. You're able to recall because Kirchhoff's law is over. Same goes with Wafia. Wafia was there in the last class, no?
Yes, ma'am.
Reem has answered. Okay, Reem has answered. Reem, E1, E2 do not write. Every value of E is same. We are considering identical cells. Others also, Reem and Sami only have their opinion. You can't think of anything, no? All of you just try. Fahad, what about you? You're always so responsive. Respond whatever you feel. I just want to know what's the maximum answer that you people tell. Rifat, you also let me know. Fahad, you know. Abia, you're also there. Okay, Fahad has responded his answer. Others also, quickly. Otherwise, we'll get stuck over here. 3 students cannot only have the opinion. No, you can have your opinion. According to you, any answer can be correct. Or even if you're not sure, just answer. Abia, Darshan, whatever you feel, whatever you feel. Yes, class. So I have to take names and individually ask you people. Abia, tell me. Yes, Abia. Are you there in the class? Yes or no? C class, the correct answer I'm telling you. So good. I appreciate Fahad, Reem, and Samia for at least trying. See, the answers are not correct. And most of the people respond what Samia you have answered 1 by ME. See, EMF is what? EMF is actually potential that we have studied. Remember, I told you even that EMF is not electromotive force something. The term is a misnomer. It's basically potential. Sometimes it is equal to terminal potential difference also. In case of parallel combination, your potential doesn't change. Net potential will be the same only. Remember, in case of parallel combination, we write equivalent potential difference as same. Clear to all of you? So net EMF will be E still. Clear by all of you? Yes or no?
Yes, ma'am.
Yeah? All right. So equivalent EMF is this only. EMF, equivalent EMF will be E. Because in parallel combination, it does not get changed. R equivalent will definitely be different. We have studied equivalent resistors and connected in parallel. So it's like 1 by R equivalent will be 1 by R plus 1 by R plus up till 1 by number of like M divided by R, or whatever is the value that you people have. So let's say 2 resistors are there. So that becomes R by 2. If M resistors are there, so that becomes R by M. So from here also you can conclude. This becomes M by R basically. So R equivalent becomes R divided by M. Remember, I have told you this, and whenever you have the parallel combination, no. If the resistors are identical, if you see the resistors are identical, if you see that resistors are identical, then what do? You just take the sum of it, and or just take the value and divide it by the number. Like if I tell you 10 ohm, two resistors having the value of 10 ohm are connected in parallel, what shall be the equivalent resistance? No need to write everything in reciprocal division form and solve it. Two resistors are identical, divided by 2, that becomes 10 by 2, that is 5. Wafia, network issues, is it fine now?
Yes, ma'am. I'm losing the connection between.
All right. So equivalent, similarly, if M number of cells are there, that becomes R by M. So you have the value of equivalent resistance. Now let's calculate the value of current. So current is what? E equivalent divided by R equivalent plus R. So current becomes E equivalent is what? E. Or you can write it ME, that's better. Just multiply it by the number of cells present. For this is for a single cell, no, that this current is for a single cell. And right now so many cells are there. So multiply this whole term by E, whole term. Not EMF. We are not multiplying the EMF by M. Remember, EMF is equivalent, EMF is E only. We are just multiplying it for the whole term. Or let me not even write it. Let's do it systematically, then you will be able to understand how did we get it. This is R by M plus R, fine till here, that's how we write. Now if you take the LCM will be M, so M will go up, that's how we got this ME divided by R plus M into capital R. This is the current that you get, where M is the number of rows present. Similarly, you can get a condition where your both of these are equal. Capital R is greater than small r. So it means R plus MR is there. Tell me, what should I equate it to? What should I approximate it to? Open question, anyone can answer. Capital R is huge. So what should I write instead of the sum of all these? Someone has answered MR, not R, only Fahad, MR. Both of you, the concept is right, Sami and Fahad. R will be there, but since it's M there, so MR will write. So current will be what? E was the equivalent EMF divided by M into R. And for here, this is R plus MR. So this will be equal to R only. So equivalent I will become what? E divided by R. These are the two terms that we write. Now I will tell you what I was telling in case of the combinations that we choose. See, NE divided by R is greater or E divided by R is greater? NE divided by R is greater. So we choose series combination because we get the maximum current. This is the maximum current. That's why we choose series combination if external resistor is greater. If your internal resistor is greater, see E by R is greater than E divided by MR. This is in the denominator. So we choose this parallel combination to get maximum current. Before going on to the questions of this part, all of you write all these things. Whichever, see, we have done a big chunk. It's an important topic and we have covered a lot of portion. I've done it together so that you're able to relate series and parallel. So while writing, it may happen that you've forgotten what did I tell you regarding the series portion. So it's okay. Text me, ask me, unmute yourself, whatever suits you. First start note down. If n is equal to 1, then we'll write 1 by E divided by 1 by R plus R. Yes, if n is equal to 1, it means there's just a single cell. Only a single cell is present. N is the number of cells. So it will be capital E divided by R plus R only, the way we have been writing for a single cell. If there are two cells, so that becomes 2E divided by 2 small r plus capital R. Whatever, just put the value of n. So if n is equal to 1, it means just a single cell has been connected in the circle. Clear? Zed, where were you? Last half an hour is left now.
Ma'am, as I already finished this chapter, I'm just here for revision. Can I?
Okay. There is one more Zed in this batch. So I got confused. You are Zed Siddiq, Mohammed Zed Siddiq.
Yes, ma'am.
Okay, Zed. There's one Zed Ahmed in this batch. So that's why I got confused. Fine, Zed. M portion. Okay, Fahad, see, M is the number of cells that are connected, identical cells. So when we were connecting them in series, in case of series, so we had the cells like this connected, and this number was considered as n. Now right now we are considering the parallel combination. So here in every row there is a single cell, so no need of n, but number of rows are variable. No, there are so many rows present, so we have taken the number of rows as m. So in a single row there is a single cell present, so you can take take identical cells in parallel. So what did I tell you? When we take the equivalent EMF, so in equivalent EMF, the potential will be the same throughout. The potential in all the branches will be the same. So we write the E equivalent as E only. In case of R equivalent, what did I tell you? If you have two resistors which are identical, or n number of resistors are there but which are identical. Right now we are dealing with the identical portion. So if there are n number of resistors which are identical, just divide the value of resistor with n. For example, if I give you value 50 ohms, two resistors are connected in parallel having value 50 ohms. So what should be the equivalent EMF? One method is that you take 1 by 50 plus 1 by 50, solve it 500 divided by 2500 by this, and then you get the answer as 25. Better way is that two are identical, divided by 2. So 50 divided by 2 directly gives you 25. Similarly, 10 ohm 2 resistors are there, or let's say 30 ohm 3 resistors are there. Divide 30 by 3, you get 10 ohm. So that becomes the equivalent resistance. So small r are connected in parallel combination. So small r is the value of resistance, m is the number of cells. So r equivalent will be what? R divided by m. Now that formula which we had discussed in the last class, or even in the earlier class before doing Kirchhoff's law, when we were discussing terminal potential, all these EMFs and internal resistance, there we discussed this formula. Remember, I is equal to E equivalent divided by R equivalent plus R. There we have just substituted these formula. So if you substitute these formula over there, you get the value of current as ME divided by R plus MR. Now tell Fahad, is it clear to you? So value will be the same of R. Yes, value will be the same. Like in the resistors, if the value of R is 10 ohm, so value will be the same because they are identical. We are not even considering it as even one resistor different. All the resistors are having the same value. That's why we are considering this. Is, remember one thing class, these portions, no, that we have done it after Kirchhoff's law, these are valid only for identical cells. Don't use these formula if different EMFs are given. So how will you calculate? For that we have done that earlier only, equivalent EMF and equivalent resistance. All right, class, let's do a numerical. So 8 identical cells of EMF 2 volt and resistance 1 ohm are connected to external resistor of 0.05 ohms Second part says external resistor of 100 ohms. You have to decide which combination you will be preferring it, whichever combination that will suit you, series or parallel, and accordingly you will find it. See, if the question asks you to calculate the maximum current, then you have to use these formula. For maximum current, this one, E by MR or E by small r, these formula. If the way it has given, find out the current. So you just have to decide the combination using these values, but ultimately you have to use this main formula. I'll show you how. So 8 identical cells are connected. So first part, A part, value of external resistor is 0.05 ohms. Value of internal resistor is 1. As we can see, what did we decide? Right now only I have given you so many examples how to do this. External resistor is greater or internal resistor is greater? According to you people. What's the comparison? Internal. Yes, the internal resistor, both of you are right. Internal resistor is greater than external resistor. Remember, I have told you right now, when internal resistor is greater, we prefer the parallel combination. So with the help of this data, what can we conclude? That the combination that will be chosen is parallel. Now, we won't use this formula. We won't use this formula because we are not finding the maximum current. If the question specifically asks you to find out the value of maximum current, then you use this. Right now we have to find the general current. General can be found through this formula. So I is equal to ME divided by MR plus small r. Just a second, give me a second. All right, so ME divided by MR plus R. So now let's put the value. M is what? M is 8. Number of identical cells given is 8. So 8 into EMF is 2. MR means 8 into capital R, that is 0.05 plus small r's value. So this is, I think, around 16. That becomes 4. So 40 and 40, 0.01. So that is 11.42 amperes, I think, approximately this. Just check. Anyone, please just check the calculation. Now, second part says what? Second part says external resistor's value is 100 ohm. It means the rest of the data will be the same. B part is R is equal to 100 ohms this time, and small r is 1 ohm. So now external resistor is greater than your internal resistor. So here you will prefer series combination. So this time it will be NE divided by NR plus capital R. So I, number of identical cells will remain the same, that is 8. So this becomes 8 into 2. What's the value of small r? 1. So that becomes 8 into 1 plus value of external resistor, that is 100. So this will be around 8 into 2, 16. 16 plus 100. So 0.148. Just check. 0.148 amperes. This should come. Just check whether the answer is right. All right, this way you have to manage the questions. Just note down the question as well as the solution. we didn't use the formula I divided by E plus R. See, who has asked this question? Fahad. See, Fahad, when the question asks you to calculate the maximum current, then you use that formula accordingly to whichever is greater. Fine. Right now, the question didn't ask you to calculate the maximum current. You just had to calculate the normal current in this question. Had it been asking you the maximum current, then you would have calculated it. Right? And Samia, what's your question? Samia says, how to decide which formula to use. See, Samia, which formula means, are you not able to decide between series or parallel, or the same question that Fahad asked? I by R formula, these formula, or these M by EMR? Which one, Samia? Series or parallel? See. Just compare external resistor and internal resistor. If you see internal resistor is greater than external resistor, then you have to use the parallel one. If your external resistor is greater than internal resistor, you use the series one. Reason why are we doing this? Reason for that is that in case of parallel combination, if we use this formula, no, then we get more current, and more current is best for us. Similarly, for external resistor greater, we use the series combination. So that gives us more current. That's how you decide, just by looking at this comparison, these and these. Fine? Did all of you write this? One last portion is left. Let's just end with current electricity so that we can start with magnetics next from the next class. Done, Samia? Your query got clear? Now, the last topic is mixed grouping. We discussed series grouping differently, parallel grouping differently. What if series and parallel grouping are done together? Means there was a single cell in each row in case of parallel, and in case of series, there was a single row. But what if both are combined? Means in each row there are n number of cells and the number of rows are m. You can get this kind of question as well. So if mixed grouping exists, in case of mixed grouping, see, equivalent EMF for this. Equivalent EMF will be what for this? This will be NE, and equivalent internal resistor will be NR for a single row. It means I can reduce my circuit in this manner. And so on, connected with the external resistor. This is NENR. 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 See, what did I write? If you reduce the circuit, E plus E plus E plus E in series, what did we write? If you have everything connected in series, you have to write it as NE. Now, if all the resistors are connected in series and number of resistors are N, so that becomes NR. So each row can be written as like this. There are M rows, so M rows can be written in this manner. Clear till here or not? Any doubts till here? Any part you want me to repeat? First, let me know till here. Then I'll move forward. Clear? All right. Now you just have to focus on this circuit. All right. Now you just have to focus on this circuit. And E is now the means value of EMF that you have, and NR becomes the value of internal resistance for you now. So equivalent EMF is what? NE, because they are connected in parallel. So equivalent EMF will be NE. Like in parallel combination, earlier EMF was E, so equivalent EMF came out to be E. Right now equivalent EMF is NE for a single, so equivalent EMF will be NE. So 1 by R equivalent will be 1 by NR, 1 by NR plus M by R. So R equivalent will be what? NR divided by M. Whatever you studied for parallel, no, that is getting applied. It's just that we have the value of this as this and this as this because of series grouping as well. Now put the values in the formula of current. See, I will be equal to what? I equivalent EMF was what? NE. R equivalent is NR by M plus external resistor. So on taking the LCM, current's value will be NME divided by NR plus MR. This is the formula for mixed grouping. This can come in your exam. It's a part of your syllabus, so don't neglect it. But yes, it comes rarely in your exam. One more thing. Or okay, just write it till here. Any doubts? Just ask me. Others also, if you have done, just text me. Like Samya has written. So few people have also written, just keep on writing done. All right, so I think most of you have completed. So that ends our current electricity lesson. We'll be starting with magnetic effects of electric current, that is moving charges and magnetism. Chapter number 4 of NCERT. We'll do it in the next class. Fahad and Abia, I'll send your solution of the doubt on WhatsApp. By tonight, I'll send you both of you. All right. Oh, so fine class. Thank you. Stopping here. We'll meet in the next class.